All right, D's other option is to adjust the radius. So if we keep the height at 5 centimeters, what would the radius need to be to make the cylinder have a volume of 64 cubic inches? So this time we're going to use the 64 again, but we're going to replace the height with 5, and we're going to solve for r. So V equals pi r squared h, and we know that the volume, we want it to be 64. Pi, we don't know what the radius is, and the height is 5. So just like before, we're trying to solve for r, so we're going to divide by 5 pi. And you want to keep this in parentheses so that these will cancel. So r squared equals, now I'm not going to do this yet because I still have another step. So this is 64 over 5 pi, and I'm going to take the square root of it, and that will give me r. So when I put that in my calculator, I got the square root of 64 divided by, and then in parentheses, put 5 pi. And that's 2.02, approximately 2.02 centimeters. So a little bit more than the 2. We knew it would probably be a little bit more because we weren't that far off. So here's that work. Now, last year, Coach Duval showed you how you could type fractions in. If you do it that way, and I don't even know, I know it's something to do, I don't even know. If you do it that way, you don't have to put parentheses in the denominator. So that's only if you're using the division bar. I mean, it's not going to hurt to put them, but okay. So then, now that she's figured out the volume, and to get the volume exactly at what she, or as close as she can get it, then she's got to start thinking about the packaging, and that would be the surface area. So then she says it's time to go see Penny, and she's got to figure out first how to calculate the surface area of a cylinder. To do that, we're going to look at the net of it, and then how could she minimize it? So let's look at what the net looks like for the cylinder and come up with our formula. So it says the net of the cylinder consists of 2 circles and a rectangle. Okay. So the circles are your bases, the top and the bottom, and then this lateral surface area is that circular part, and when you unroll that, you get a rectangle. So we know the dimensions of the circle is the radius, and we know the height of this rectangle, but how do we calculate this length of the rectangle? And so if you'll remember, the length is the distance around, which is circumference. So then we have our formula that we can use to find the surface area. So the surface area of a cylinder is, it says the area of the bases, and there's 2 of them, okay? So your surface area is 2 pi r squared plus, and then it's the area of this rectangle, which is length times width, so 2 pi r h. So it's just the area of the circles, and then this rectangle here. And this is the part that most students struggle with, is trying to figure out what that length is, and that is just the circumference of the circle. If you were trying to find, like if you had a can and you didn't need a lid, and you were trying to figure out the surface area of that, then you wouldn't have a top. You would only have one base. So in that case, you would just do pi r squared instead of 2 pi r squared. So this formula gives us the entire surface area. You take the lid off or the bottom off. If you want to just find the lateral area, which is just the rectangle, then that's just this part, the pi r squared h. So knowing the formula and then how to change it depending on the type of problem that you're given is very important. So this kind of just goes with what I was just saying. It says you memorize formulas for volume and surface areas in other classes, but sometimes you don't understand where they come from or why they work. So our goal is to not only remember the formulas, but see and understand to make the formulas make sense, and that will help you remember them better for the coming your future math classes. Okay, should be pretty easy. Just pay attention to whether you're finding volume or surface area, and you've got your formulas, and you should be good.